better understand earthquakes and their effects, the Southern California Earthquake Center, known as SCEC, coordinates a research program funded by the National Science Foundation and the U.S. Geological Survey. SCEC comprises over 600 academic and government researchers working at 62 institutions worldwide. Located in the heart of Los Angeles at the University of Southern California, SCEC conducts earthquake system science using Southern California as a natural laboratory, translating basic research into practical products for reducing earthquake risk. The Undergraduate Studies in Earthquake Information Technology internship program is vital to this effort. Each summer, students from institutions nationwide arrive at SCEC headquarters to tackle a scientific grand challenge that furthers earthquake science and promotes community education and preparedness. The UseIT interns have developed a software 3D visualization platform to view earthquake datasets and created working prototypes of computer games for earthquake science education, risk reduction, and decision-making. Since the program's inception in 2002, over 120 students from more than 38 institutions have participated in the UseIT program.
Well, UseIT, it's an amazing program. UseIT stands for Undergraduate Studies in Earthquake Information Technology. And what's really neat about it is that about 20 people a year come from colleges and universities all over the country, and they represent majors, a very diverse group. We have students that are majoring in physics, in biology, chemistry. Some people are law students or pre-law students in this case. Computer science, earth science. And it's a bunch of people that have many different backgrounds, and it's a very important component of this particular program. All the students that come to the UseIT program have three characteristics that I think that are key. They're diverse, they're dynamic, and most importantly, they're very determined.
The idea behind the UseIT Grand Challenge is to pose a significant geophysical problem that the interns can solve in the brief summer period available to them.
A multidisciplinary group of earthquake scientists and engineers, known as the Working Group on California Earthquake Probabilities, produced a new uniform California earthquake rupture forecast in 2007. Ned Field, a geologist with the U.S. Geological Survey, was the project leader.
The USERF report is a forecast of all possible earthquakes in the next 30 years throughout the state of California. And it is being used now to help guide building codes, how engineers are required to design buildings to withstand these earthquakes, and it will likely be used in the future to help establish insurance rates for homeowners, earthquake insurance. So there have been several working groups on California earthquake probabilities that have developed these reports. What's really unique about this one is we did a statewide model applying a relatively uniform methodology throughout the state. Previously, they either focused on Southern California or the last one actually focused on the Bay Area. So ours was really unique in the sense that we looked at the entire state of California to get a more uniform treatment and a complete treatment.
When the USERF report was released, we did have a number of products, fact sheets, different types of images and such that were designed to be understood by fellow scientists, but also for the general public. But how do you present all the different aspects of the data, the different faults that have new probabilities now, the regional probabilities, etc., in a way that the public can understand? And also, how do you maintain all this data that's at the core of USERF and allow scientists years from now to come in and work with the data and understand what was done originally for the USERF study? And so for the UseIT Grand Challenge, there are a number of different components.
To communicate the value and content of the USERF study, the 2008 UseIT interns divided into teams to tackle specific tasks. One team pioneered a process for archiving the entire USERF report and all of its datasets in the USC Digital Library System.
Okay, so this is the first time that any kind of digital archive has been created for SCEC. The digital archiving group is responsible for digitally preserving the USERF-2 report and all of the materials related to it. So we've kind of laid down a roadmap for either future interns or the scientists themselves to archive work.
A second team enhanced and created new capabilities in SCEC-VDO, a 3D visualization software now used by a growing number of SCEC scientists and educators.
From the start, the development team for SCEC-VDO has had several explicit goals to address the grand challenge. We want to add participation probability, visualization and calculation, regions of interest functionality, and improved movie-making abilities. But as with any development project, there are several other fronts that have to be addressed. We have to fix the old, which means stability, bug fixes, and saving and loading. We have to bring in the new, which means the grand challenge and our explicit goals. We'd love to broaden the user base for SCEC-VDO. And there's always this age-old battle between ideality and practicality. On the one hand, the ideal solution is a great long-term solution, but it might take longer to implement, whereas the practical solution solves the problem quickly, but it's not as good of a long-term solution. To make things more complicated, we have to carefully prioritize to finish certain functionalities so that our SCEC-VDO movie makers can use it before the end of our internship.
I mean, the four major changes were the ability to display the USERF-2 probabilities. We can actually visualize the probability that a particular region of the globe will be involved in producing a major earthquake over a period of time. Secondly, in order to help display videos for SCEC-VDO, actually relevant information on each of those videos, we can put overlays on the videos as they're being rendered. This way you can, say, display a legend or whatnot. Third, we have the ability to display, or rather project regions of interest onto the globe, so we can highlight portions of the globe as well as filter out data according to those regions that are highlighted. And lastly, a major change was made to the SCEC-VDO code base, which will hopefully make the SCEC-VDO more amicable to future development by outsiders. And this will hopefully make a SCEC-VDO community effort.
Using the newly developed SCEC-VDO plugins, a third team of interns created animations to visualize and explain the significance of the USERF study.
We started out, we took the USERF report, we broke it up into components, and the first set of movies were basically an introduction to the USERF report. Then we made one for fault models. It shows the two different spatial geometry in the active faults. It's mostly in Southern California. We made one which is probably the most important. It's the probability of an earthquake. That's the point of the USERF report, to forecast the probability.
The combined research efforts of the 2008 UseIT interns have resulted in improved tools for communicating the value and importance of the USERF study.
So the key point here is the experience. This grand challenge is an authentic thing that goes on. And this authentic experience allows individuals to see that their work actually has an impact on how the information is presented.
Now, each year we try to choose something very challenging, and I always think it's going to be too hard. They're not going to be able to accomplish what we're asking them to do. But every year I'm proved wrong. It's amazing how much they do. And you know, this year's program is no exception.
These products are now available to a more diverse audience in the digital world. The Chino Hills earthquake sequence began with a magnitude 5.4 main shock and was followed by more than 40 aftershocks. The earthquakes occurred near the intersection of three faults: the Strike-Slip-Whittier Fault, the Chino Hills Fault, and the Peralta Fault. The data produced by the USGS and Caltech indicates that the main shock was most likely to have been caused by oblique slip, part thrust motion and part strike-slip motion on one of these faults.